Hey class, today we're going to focus on the empirical rule. So we're going to start off looking at what's called data distribution. Okay, with data distribution, we can see how data values are clustered. So when you look at this one right here, you see that the tail of that graph goes to the right. So that would be called positively skewed. Okay, the tail is going to the right. That means that when you have a lot of your data over here, let's say that we have some very, very bad test scores here, and then we have a few good test scores, that those good test scores will bring that average up. Okay, now if we had that reverse, if we had a lot of good test scores and just a few bad test scores, then it's going to skew that data to the left. So that's called negatively skewed. Okay, with this one right here, this one would be considered a normal distribution. So you see where everything would be symmetric with the mean. The mean, the median, and the mode would all be in the middle. So everything would be symmetric. So this one's called a normal distribution. And in order to use what we're going to talk about today, the empirical rule, it has to be a normal distribution. So with the empirical rule, you're going to see that this would make what's called a bell-shaped curve. So with the normal, we're going to have a symmetrical bell-shaped curve defined by the mean and the standard deviation. Now, this mean, that is pronounced as mu, okay? So you can see it's kind of like an M with a U, so you would pronounce that mu, like what a cow does, moo, moo, moo. But it's mu, okay? Then you have this for standard deviation, that's called sigma. Now, recall that with your standard deviation, it tells how spread out the data is. So it tells the spread of the data. So the standard deviation is going to tell us the spread of the data. The mean is going to tell us the average. So I'm going to come over here. The mean is going to be the average. And the standard deviation is going to tell us the spread. The area under the curve, represents probability. Probability is the likelihood an event will occur, okay? So probability is the likelihood that an event will occur, with the total area under the curve being a 1. We'll put under here probability, the likelihood an event will occur. Now, when you think about probability, need to have an E right there. Likelihood, it's spelled, let me go back, LiceLIHOOD. I left that E off. So if you think about probability, most of the time that's represented either as a decimal or a percentage, okay? Now, in this section, probability and area are going to be one and the same, okay? So the probability is going to be under this curve, the likelihood that certain things will occur, and that is going to total a 1 or 100%, okay? So that totals 1 or 100%. So remember the first thing, in order to use the empirical rule, it has to be normally distributed. So it has to look like this. Okay, you have to have a bell. So since it is normally distributed, we're going to be able to go down and I'm going to talk with you about what the empirical rule implies. Okay, the empirical rule is based on the mean and the standard deviation, okay? Approximately 68% of the data falls within 1 standard deviation of the mean. Approximately 95% of the data falls within 2 standard deviations of the mean. And approximately 99.7% falls within 3 standard deviations of the mean. What this empirical rule does is it allows you to quickly estimate probabilities. So it allows you to quickly estimate probabilities when dealing with a normal distribution, which means nothing should be skewing the data. Okay, if you take a look at your formula sheet that I attached with the unit, you can see that we are down here to the empirical rule for today. So your next test will deal with chapter 2. So we are getting close to finishing. I believe we might have 1 section left. So the test should be coming up. You can use the information on your formula sheet. So right here with that rule, it tells you 68, 95, 99.7. Tells you the 1, the 2, and the 3. So that's the part you can use. But you have to know how to draw this curve, and you cannot use this, okay? You can use that on the formula sheet, which were these numbers. But other than that, you need to be able to break it apart with the curve, and I'm going to show you how to do that. Okay, the mean is going to be in the middle. That's going to be what's called your average, okay? When you look within 1 standard deviation to the left and 1 standard deviation to the right, you have 68% of your data. So if I'm dividing that into 2 symmetric pieces, that would be 34% on each part. Okay, so notice that this portion right here represents 68% of this curve. So that's more than half of your data is located within that one standard deviation. Okay. Then you go out to 2 standard deviations and you see that that would be 95%. So what you would do to divide this out is you would do the 95 and you would minus the 68. Okay, now you're going to divide that by 2. So that tells you that 13.5% would be in each of those 2 regions. So 13.5% would be in that region, but if you look at those regions all put together right here, which I'm color coding here in pink, you'll see that this whole thing right here should total 95%. So if you think of 95%, that is most of the information. All you're lacking is 5%. So most of the answers would fall in between this area. Okay, that would be considered usual. Things that would fall within 2 standard deviations of the mean is considered usual because that is representing 95%. Now, what those mean, extreme to the left and extreme to the right, these would be the small cases. Not saying that it cannot happen, but it is very unusual. Okay, so anything that lies outside of 2 standard deviations is considered unusual, which is not likely. So anything out here would be unusual, and on that side also. Now, anything that's unusual to the right would be, for an example, if somebody made a perfect score on the ACT. Okay, that has been done before, but it doesn't happen very often, so it's considered an unusual. Over here, if you look at the very far left, you could look at someone who might be 2 or 3 foot as an adult. Okay, that is considered unusual. It can happen, but normally we are not that high. Okay, so you're going to have things that are considered normal and things that are considered outside of normal. Okay, so outside, if you notice, 3 standard deviations would be 99.7% of your data. So we'd have 99.7 minus 95. I'm going to divide that by 2 for those 2 symmetric regions, and we would have 2.35% in each of those. 2.35%. Now the whole thing would be 100, okay? So after 2 standard deviations were considered unusual, so anything out in this area, okay, because 95% of your data would lie there in the center. So now we would go what's called asymptotic to the x-axis, kind of like an asymptote. So it's going to run completely to that x-axis and total 100%. So I'm going to take 100 minus 99.7. I'm going to divide that by 2. So you would have a 0.15 way out there, 0.15%. and the whole curve is totaling 100. So again, these would be the data points, and that is on your formula sheet, but you really need to know how to construct this by hand because that's how you're going to do the problems. Okay, so as we start the first question, when you go through these questions, the first step that you want to do is you want to see if it is asking you if the data is normally distributed. If it is telling you that the data is normally distributed, then currently it's wanting you to use this empirical rule. Okay, the very first step that you do is you have to draw the bell-shaped curve. That is your very first step. So you're going to draw out the normal curve. You're going to draw the line down the center. That's going to be your mean. You're going to then make 3 standard deviations to the left and the right of the mean. Okay, so we're going to go first of all, and I'm going to put the mean here. We would go out 1, 2, 3 standard deviations to the right, and 3 standard deviations to the left. Okay, next you want to put your percents in the bell-shaped curve. So now I'm going to put the percents that we did just a moment ago. Now you can memorize these if you want to. Some people find that it's just easier to memorize and they start remembering them after writing them a few times. Okay, next you're going to read the problem. So it says the weights of 50 football players. So my sample is 50. So my N is equal to 50. It is normally distributed. The mean is 178 pounds. So the mean is going to go in the middle. That is the average of the football players on this team, 178 pounds. The standard deviation is 8 pounds. So what that means is when you're going to the right, they're getting bigger by 8 pounds. When you're going to the left, they're getting smaller by 8 pounds. Okay, so this would go in order as a pattern of 8. So the standard deviation is 8. So I would go 178 plus 8, 186 plus 8, 194 plus 8. And then I would go to the left and subtract 170, 162, and 154. Now you might want to draw those lines with those numbers where you know where that number is located. Now the question says what percent. So remember, the empirical rule allows you to quickly estimate percents and probabilities when you have normal distributions. So what percent of the players weigh between 178 and 194 pounds? So we're looking at 178 and we're looking at the weight to 194. Okay, so we're looking in between those numbers. So you go over here and find 178 and you go out to 194. Okay, and then I'm just going to color that area. That is the area that it's talking about. So what you do with those percentages is you add those up. So this would be 34% plus 13.5%. So you'll just add those up to get your total, which would give you 47.5%. Okay, see if you can get the second one. What is the probability that a player weighs at most 170 pounds? Now, at most, that's the most they can weigh. So for your inequality, if the most it can be is 170, we need the weight to be less than or equal to 170. So if you're looking at less than, you're looking at the numbers to the left of 170. So you're looking at those percentages to the left of 170. So you would add 0.15, 2.35, and 13.5. So that would be 16%. So we're just adding those up. Okay. Now for letter C, what is the probability that a player weighs less than 162 pounds or they weigh more than 194 pounds? So we're going to have to find 162, and we're going to look to the left of that because we're looking for less. Remember, left, less. So we have these percentages right there in that little area. Then I look for greater than 194. So that would be this other little area right there. Okay, so we have these two areas. So you would take 0.15 plus 2.35 plus, we have a 2.35 again, and a 0.15. And that should total 5%, because if you remember, all that other area was 95%. So we're looking at the two unusual regions, which were on the outside. So we get 5. Now it's asking how many players weigh between 170 pounds and 186 pounds. See if you can get your percentage. There's 170, and there's 186. So it looks like that area is going to be 68%. Now this question does not ask about percentages, but it asks how many players. So we have to change the percent to a decimal, move that 2 places to the left. We had 50 football players. So we look at 68% of 50 to figure out how many football players that would be. So 0.68 times 50 would give you 34 players. So approximately 34 players would weigh between 170 and 186. Okay? Now, if you feel like you understand, you can go ahead and do that other page and then come back. All of these questions will be done basically the same. the very first thing you have to do is go ahead and put the numbers on that bell curve. Now, if you look while you're doing that, I also attached this for you, and it has the numbers up there, and this should be empirical rule right there. Now, remember that most of the data is going to lie in the middle. That represents the usual, which is 95%. Anything more than 2 standard deviations to the right or to the left would be considered unusual. And then most of the data, like we said, is usual with that 95%. You have your mean. You take your mean and add the standard deviations. Make sure you have a pattern going on, and then you subtract, okay? Okay, so we're going to have 34, 34, 13.5, 13.5, 2.35, 2.35, and 0.15. Good job if you got that without looking. Okay, we have 120 test scores. That's my N. It's normally distributed. We have a mean of 82. The mean goes in the middle for your average. The standard deviation, I would go ahead and connect those as you're going and putting the numbers underneath, just because it might help you divide out that. We're adding 5 each time, so I'm going to add 5 and continue that pattern. Those numbers are right under that line, okay? Then I'm going to continue the pattern to the left. And all of those should go by a distance of 5 units. So you're trying to figure out the scores between 72 and 87. So you're trying to figure out what those scores would be, the percent of the people who scored between 72 and 87. So here's 72. You would look all the way to 87. If you see where I drew that, think about that as the x-axis, okay? And then you would just shade the area above it. And then you add those up. So I believe that would be 81.5%. And again, you would add 13.5, 34. You see the 34 that's shaded. And that gives you the 81.5. Now we're looking for the probability that a score is greater than 77. So try to find the area to shade. Greater than, you would go to the right. So here's 77. I would be talking about everything to the right of that. So I would be adding all this portion here that I'm putting in pink. I would add all those numbers. So go ahead and add those. And that should give you 84%. What is the probability that a score is less than 82 or I'm just using X this time, greater than 92. So look for less than 82. Or greater than 92. So I would add that blue portion. So I would have a 0.15, a 2.35, 13.5, 34, 2.35, and 0.15. So that gives us 52.5%. About how many students scored outside 2 standard deviations of the mean? Well, you can look, or you can remember what I told you earlier. If you're outside 2 standard deviations from the mean, okay, think about that. This would be your mean. Have 1, 2, 3, -1, -2, -3. So you're outside 2 standard deviations. So it would be here and there. So if you recall, that would be 5% because the other portion is 95%. So we would have 5%, and you could add those up if you wanted to. So we would have 0.05 times 120 to see about how many students that would be. So we're taking 5% of 120. So that's approximately 6 students. So you can see out of 120, 6 students is not that many, and that's what would lie outside of that area. So more than likely, the things are going to lie within that 95% because all the other students would have lied in there. So you would have had 120 minus 6, and you see that would be 114. Divided by your 120 gives you the 95%. Okay? So looking at number 3, go ahead and see if you can label your curve. Draw your mean in the middle. So we do notice it's normally distributed. We have the price of a gallon of regular gas at 75 gas stations. So N is equal to 75. The mean price of the gas is $2.05. So that's the average. The standard deviation is 4 cents. So it changes by 4 cents, either higher or lower. So this would go higher to the right, 209 for that line, 213, and 217. Go ahead and fill in to the left. You would have 201, 199, and 193. Now, remember when you're doing this pattern should be consistent. So if you notice, and I'm adding that 0.04. So it was 193 plus 0.04 is the 197. Then I have the 201. Then I had my mean here of, excuse me, I didn't add the 0.05. Let me go back, 2.01 to 0.04, I mean, because that should give me 205. Add the 0.04, 209, 0.04, I added 204. That's really not the right thing, is it? 0.04, 213, and 0.04 again is 217. So make sure the pattern is consistent, okay? Here's going to be my mean for my average. Now see if you can answer the questions. What percent of gas stations sell a gallon of regular gas for less than $1.97? That should be 197. It looks like 199. Fix that. Okay, so we're going to do less than that. So that would be 2.5%. What percent of gas stations sell a gallon of regular gas for at least is greater than or equal to 17? So that would be 0.15%. What is the probability that a gas station sells a gallon of regular gas for less than 197 or greater than 205? So less than 197, I think we did that one up there, which was this portion right here, which was the 2.5, plus greater than 2.05, now you can add all those up, but you probably noticed that that is 50% of that curve. And you see that would be 50%. We would add the 2.5 and get 52.5%. About how many stations sell a gallon of regular gas for no more than 201? So no more than, less than, or equal 201. Now, if you remember, that was the 2.5% right there. So you could add that to the 13.5 and get 16, or you can just add up all those. Or you can remember that was 2.5, add that to 13.5 would be the 16% we said. Okay, but the question is asking how many stations. So what we have to do is take 16% of the number of gas stations. So we would do 0.16 times 75. And that's approximately 12 gas stations. Okay, so we have to label We have 120 keyboarding students, so that's my sample. They're normally distributed with the typing. The mean is 45 words per minute with a standard deviation of 6. So 45 plus 6, 51, plus 6, 57, plus 6, 63. Then we're going to go backwards, 39, 33, and 27. And we'll draw those lines here. And now if you want to pause and try to answer the questions. How many students can type at least 39 words a minute? So here's my 39 and above. So we're going to add up all that. And that gives us 84%. Now it's not asking for percent, but how many students? So we have to take 84% of 120. Which gives us 100.8. So I'm just going to round that to approximately 101 students. About how many students can type within one standard deviation of the mean. So let's think about that for a minute. This would be my mean. That's one standard deviation to the right and one standard deviation to the left. So we're looking within one standard deviation. If you remember, when we started the lesson, that represents about 68% of your data. Now we're looking for how many students, so we're going to change that to 0.68 and multiply to 120. So that's approximately, I'm going to round that up to 82 students. Students need to be in the top 2% in order to be eligible. Now this would be the top, okay? This would be the bottom because that's below the mean. This is above the mean. So they need to be in the top 2%. This would be like a 0.15%. Then you would add that to 2.35 to that, which we talked about was 2.5. So that would be the top 2.5%. So this student, Carla, she's typing 56 words a minute. So it would be somewhere right there. She is in the top, but she's not in the top 2%. So no, she is not eligible. I believe there was one last handout for today that was attached, and I believe it dealt with the situation with the farm. So I'm going to let you go ahead and copy this portion right here. I think it was this portion right here. Remember that it's a bell-shaped curve that shows how data is distributed from the mean. That's what the normal distribution is. When you use the empirical rule, remember that it works with just normal distribution, okay? And it's going to tell you how much percent or proportion falls within each standard deviation. So remember, your mean and your average is going to be in the middle, and then you would look left and right. So recall, this was in the information. 68% was one standard deviation, 95 2, and 99.7 was 3. So what we're going to do is we're going to take the information about the farm and we're going to try to do the problem. So the problem tells you to solve using the empirical rule. So when it talks to you about that and it says normal distribution, go ahead and draw an x-axis. Go ahead and put like a hash mark, and it helps you draw this and just kind of go up for the mean, for that average. Okay, then you can draw some other hash marks, but not quite as high, but keeping those kind of symmetric. You can see that's not really symmetric right there, so I'll bring that up a little bit more. And then I'm going to space those out. And that might help you a little bit so you get a little bit better drawing these, because sometimes it can be kind of difficult, especially at first. But once you get the hang of it, it gets a lot better. Okay, so right here, go ahead and label. Remember, we're going to have 34, 34. Put your mean in the middle. Good. You have the 13.5 and the 13.5. Then you have the 2.35 and the 2.35. And the 0.15 and the 0.15. Now, always double check that you're totaling correctly, especially when you do it by hand and the chart's not there. Uh-oh, I hit a wrong number there because we know it shouldn't total 3,000. I went way too fast. Let me go back again. There we go. We got 100. Okay, so we got 100% for under the curve. Okay, now we're ready to look at the problem. So it tells us that the mean value for the farms is $1,500. So I'm going to put $1,500 right there for my mean. Now my standard deviation is $200. So go ahead and see if you can label to the left and the right with your $200. Okay, so we've got 1,500, so this would be 1,700. Then we would have 1,900 and 2,100. This one would be 1,300, 1,100, and 900. Okay, remember they're supposed to be changing by 200. So when you're checking that, you want to add and make sure you didn't mess up. And everything follows a consistent pattern, because I keep showing you this because this is where most people do mess up. They mess up with their adding and subtracting, just something real simple, and then it messes the whole thing up. So the question is asking, Estimate the percent of farms whose land and building values per acre are between $1,300 and $1,700. So the answer to that question would be 68%. So 68% of farms, land and building values per acre are between $1,300 and $1,700. So 68% of those farms. Okay. So remember, if it's talking about normal and estimation with percentages, the empirical rule is pretty quick to help you find that information. Also remember that sometimes you have to put a sentence, okay, with statistics. So you might want to add to that 68% of farms have land and building values per acre of $1,300 and $1,700. Remember that one standard deviation is 68%. The closer to the mean is more likely, but two standard deviations is still normal. But anything bigger than 2, which would mean 3, is very unusual. Okay, hope you learned a little something today, and I hope you have a great day.